Hi, I'm Richard. I'm a speech and language therapist and a lecturer based in the UK. In this video, I will explain how you can use the PALPA subtest 48 to assess the single word reading comprehension of someone with aphasia after a brain injury. The PALPA, or to give it its full name, the Psycholinguistic Assessments of Language Processing and Aphasia, is a large battery containing 60 subtests which assess auditory comprehension, reading, speaking and writing. These 60 subtests allow you to identify specific language difficulties underpinning these broad skills. The best way to assess single word reading comprehension is PALPA subtest 48, written word picture matching. This is because written word to picture matching tasks tap all three stages of reading for meaning: identifying letters, recognizing these letters as a familiar written word, and accessing the word's meaning. You might choose the PALPA 48 after a screen or formal assessment such as the Brisbane Evidence-Based Language Test or the Comprehensive Aphasia Test if you've noticed that someone has difficulties matching written words to objects or pictures and want to explore this in more detail. PALPA 48 is appropriate for this, but just keep in mind that it only assesses high-frequency imageable nouns, so common words that can easily be shown in a picture. Before you use the PALPA 48, you need to check for visual difficulties. Does the person wear glasses and are they available now? Has their vision changed since their injury? Acquired brain injuries can cause a range of difficulties such as hemianopia, where someone loses half of their visual field in both eyes. They may develop visual neglect and not notice or fail to respond to stimuli on one side of space. You can also have different kinds of visual neglect which affect reading specifically. They may have damaged pathways which control eye muscles, so they end up with double vision, or nystagmus, which is involuntary, often constant eye movements, which can make visual acuity much worse and make reading extremely fatiguing. Or something called convergent insufficiency, where the eyes struggle to look inwards and focus on tasks close to the person, like looking at a book. Or maybe they've got difficulty with saccadic eye movements, which are the tiny eye movements that we use to jump smoothly along a line of text or between lines. Or maybe they've got visual agnosia, where the eyes work themselves, but they cannot recognise objects that they visually perceive in the brain. Now this is relevant because of how we tend to assess reading for meaning. Sometimes issues may be documented already or suspected due to the nature of the injury itself, such as having a right hemisphere stroke or traumatic brain injury. But sometimes they are only observed when you assess someone with functional tasks such as reading itself. And now I will cover a lot more of these visual difficulties and how they impact reading specifically in future videos. So how do you administer the PALPA 48? To present as a marking form gives you specific instructions on how to administer the subtest, but as with all written word to picture matching tasks, you show a page with a written word in the centre, and on this assessment there are 5 pictures around it. The person then reads the word silently and points to the picture that matches. It's important that they do not read the word aloud, and I'll explain later why. Now I mentioned that there were 5 pictures on the test. So 1 is the target obviously, and the other 4 are distractors or foils. These include a close semantic distractor, a distant semantic distractor, a visually related distractor and an unrelated distractor. Selection of any one of these distractors or foils suggests difficulty with reading, but for slightly different reasons. Let's discuss what the brain does when someone reads the word in the centre of the page using the cognitive neuropsychological model of language processing, or cog-neuro. John Pearce, an Australian speech pathologist, has produced an excellent introductory video on the cog-neuro model, which I will link in the description below, if this is new to you or if you want a refresher. I will cover how reading works at each stage of the model and perhaps go into a little bit more detail than John did at times, but the focus will remain on how the model is being used when assessing patients in clinical practice. At the visual orthographic analysis, the brain identifies marks on the page as letters. Jeremy Purcell et al. Have a lovely diagram which breaks this process down into different stages, and it shows you what happens when someone reads the word bat. The initial stage is a general visual process not specific to reading, where the basic properties of the stimulus, the edges, the orientation of the lines, contrasts, etc. are processed. At the next stage, the stimulus is segmented into separate characters and the shape of each character is represented. So for example, the vertical line of the letter B. This is where things like different fonts and handwriting versus typed letter differences are processed, as they represent different distinct patterns of visual features. The allograph stage is where these combinations of character shapes are recognised as a canonical description of a letter's shape, i.e. what the whole letter should visually look like. There might be different allographic forms for a letter if they are geometrically distinct from one another. So for example, a lowercase a with a loop tail versus one that is open versus one that is uppercase. They all look very different, so they each have different allographs. The final stage is the identification of the abstract letter identities separate from their visual form. So we mentioned that there were 3 different allographs of A. At this stage, these would all activate the same abstract letter identity A, and the concept of A being the first letter of the alphabet. The second job of the visual orthographic analysis is to note the position of each letter in the stimulus. This helps distinguish between words with the same letters, such as bat and tab in this case. There are different theories about how this works, whether letters are tagged into fixed slots, or is the coding dependent on the letter's relationships to its neighbours in the word. But for the purposes of this video, a traditional slot-based coding procedure produces something like B1, A2 and T3 for the word bat. The last job of the visual orthographic analysis is to parse the letters into graphemes, which are the smallest units of written language that represent a distinct sound or phoneme. The word bat has 3 letters and 3 graphemes. Each letter matches one sound. The word owl has 3 letters but only 2 graphemes. The orthographic input lexicon stores visual word recognition units representing all previously known spellings. The abstract letter identities identified above simultaneously fire and activate multiple spellings in parallel based upon letter and position matches. The word bat receives the strongest excitation because it is a known spelling in the lexicon. It starts to inhibit other words which only partially match the stimulus because they contain some but not all of the same letters, such as words like bad, bag, ban, bar, or words that do not match the length of the stimulus, such as bath, bathe, and battery, etc. Once the competition resolves, the visual word recognition unit for the spelling bat reaches its recognition threshold and the spelling is activated. The semantic system stores word meanings representing all previously learned words. As the spellings were activated in parallel in the orthographic input lexicon, these spill over into the semantic system, so the meanings of words like bad, bag, ban, etc. are partially activated simply because they look visually similar to the target bat. Once the competition resolves and the spelling bat is activated, then semantic neighbours are activated for this word, whilst the visual lookalikes are inhibited and fade away. The word bat is a homonym, a word with one spelling but multiple meanings. So the semantic system activates the animal meaning alongside the sports equipment meaning and, in theory, the verb meaning to bat something away. But let's just stick to nouns for the time being. For the animal meaning, this would activate semantic neighbours with shared features such as bird, owl, etc. For the sports equipment meaning, this would activate semantic neighbours such as racket, ball, etc. The brain does not know which is the appropriate meaning to activate, so it keeps both active and they compete with one another. At this point, the task draws upon additional perceptual and cognitive skills which are not explicit in the cog-neuro model. The person has to look away from the spelling, but must sustain activation of the concept in their working memory. They start to visually scan the 5 pictures and must identify the objects depicted in the black and white line drawings. Each new picture activates alternative concepts that act as interference and need to be inhibited as they are incorrect. As soon as the person sees a picture of a flying mammal on the page, the brain reinforces that target meaning, allowing it to suppress the competitor, the sports equipment meaning, and they point to the picture of the bat. This process is challenging for a homonym like bat, and it becomes a test not only of a person's ability to correctly access the word's meaning in semantics, but also to inhibit the incorrect meaning as well, i.e., it's taxing someone's executive function as well as their language skills. So that's it. That's what the brain does when someone reads a word on a page and selects a picture on a written word-to-picture matching task. Now let's step back a little. Earlier I said people should not read words aloud, and this was very important. Now this might feel very strict when you're administering the assessment and potentially still trying to build rapport with someone, but the reason it's so important is because reading aloud stops PALPA 48 from being a pure test of reading for meaning. Saying the word aloud bypasses the semantic system to the phonological output lexicon. Once they hear themselves speak, they access the semantic system through their auditory pathway, and difficulties with reading for meaning are masked. This disconnection between orthographic input lexicon and the semantic system is called word meaning blindness. You might encourage someone to read aloud as a therapeutic strategy if it is helpful, but when completing assessments initially, we need to keep things as separate as possible to better understand the person's specific strengths and needs. Now that you've completed all 40 items in the PALPA 48, how do you interpret the results? The first step is to add up the total number of correct responses out of 40. I would turn this into a percentage by dividing the score they got out of 40. So if they scored 30, it would be 30 divided by 40 and times that number by 100, which is 75 or 75%. On the bottom of the presenters and marking form 2, you can add up the total number of close semantic, distant semantic, visual and unrelated errors the person made. Because each item has 5 pictures to choose from, if someone was answering completely randomly, they would by chance get a score of 8 out of 40 or 20%. So the first thing I would be looking at is whether someone's total raw score percentage is above chance level. On the front of the instructions for use page, there are some descriptive statistics for 32 control subjects who took the subtest, and these represent a baseline for what constitutes normal performance. The authors in the manual are quite clear that these scores are not standardised and they have not carried out any psychometrically satisfactory measures of validity or reliability, so how you choose to use this data is down to your own clinical judgment. On this subtest, the mean score for the controls was 39.47 out of 40, with a standard deviation of 1.01 and a range of scores between 35 and 40. This suggests there's quite a significant ceiling effect where maybe all but 1 or 2 control subjects receive full scores. The range of 35 to 40 is quite problematic, as it means at least one person scored 35, which is technically 4.43 standard deviations below the mean score. In your research methods and statistics classes, you likely learn that scores on assessments that are at least 2 standard deviations or more below the mean likely represent impaired language skills. So in this case, the implication is that a healthy control subject has a reading difficulty, or patients who have a brain injury and score in the normal range have no issues, which is hard to accept in either case. Unfortunately, there is no easy cut and dry way to use this descriptive data. Some neuropsychological research has found that even healthy individuals with high IQs sometimes have abnormally low scores, and there is often large intra-individual variability as well. The take-home message of one study, which I will include a link to in the video description below, was not to overinterpret the results of one subtest in isolation, which I think is sensible. If you do want to use the descriptive statistics, it would perhaps be most sensible to consider scores of 34 and below as impaired, but acknowledge that there will be some overlap between mild cases of aphasia and healthy individuals. You can also factor in their pre-morbid reading skills. Do they have a high level of education? A history of developmental dyslexia? Did they read for pleasure or use reading regularly for their job? There are very few people who would not be expected to get full marks on this subtest before a brain injury. Another area that is sometimes overlooked when looking purely at raw scores is speed of response. It is one thing to get an item correct, but if you've taken quite a long time to do this, then it is very likely that this will impact your understanding of larger amounts of text. It will be slow and effortful. So to this end, you could perhaps time how long it takes for them to give a response as another functional measure. Moving beyond descriptive statistics, the PALPA was really designed to generate hypotheses based upon item analysis. Look at the error types on the marking sheet. Is there a predominant error pattern when the person is reading? Each error type suggests a difficulty at different levels of the reading process that we discussed earlier. If someone selects close semantic distractors, this suggests a high-level semantic difficulty where they cannot suppress activation of semantically similar competitors, i.e. words in the same category that share many features. We call this a coordinate error. If the target word was bat, they might select a picture of an owl, which shares many semantic features with the bat, such as being a flying mammal, nocturnal, and they are both generally quite small, etc. If they select distant semantic distractors, this suggests selective failure to activate fine-grained semantic features. They might select a picture of a dog because coarse categories like animal or mammal are activated, but specific features such as flying, nocturnal, small are not activated enough to guide selection. If they select visually related errors, this suggests the semantic system cannot focus activation on relevant features and suppresses irrelevant ones, and is left instead to use the visual features of a picture as a cue to make decisions. The semantic information is just too noisy. They might select a picture of an open umbrella because it looks wing-shaped with ribs that resemble bat wings when spread, or something like a bow tie because it has a central body and two symmetrical wings coming out of it. If they select unrelated errors, this suggests a severe breakdown in reading altogether. The person cannot extract any usable semantic information from written words, or their semantic control is so impaired that any picture is selected. There are likely multiple levels of impairment, potentially not limited to the language system. If the person makes lots of errors, but there is no predominant pattern, this suggests severe diffuse impairment across multiple levels of the system, where no single mechanism is at fault. The semantic system is compromised, and multiple compensatory strategies are being attempted inconsistently or are failing. So you've finished the assessment and analysed the items. What next? Each PALPA subtest includes helpful suggestions on the front of the instructions for use page, suggesting further assessment. Thinking about management more broadly beyond this individual subtest though, if someone selected close or distant semantic distractors, check if they have similar difficulties accessing the semantic system on auditory comprehension tasks. In most cases, people assess auditory comprehension before reading, so now that you've done your reading assessment, you'd be able to compare performance across input modalities now. If both listening and reading were impaired, this suggests a central semantic difficulty. If you observe any difficulties with their speaking as well, then it almost certainly points to a central semantic deficit, as this negatively impacts all input and output tasks. If performance on reading was impaired, but their auditory comprehension was fine, you could administer more complex reading tasks assessing semantics, such as written synonym judgments, or, perhaps more usefully, you could look at assessing their reading comprehension at sentence or discourse level, as this will give you a much better idea of the functional impact. Most people who struggle at single word also have difficulties at sentence level as well as discourse level, simply because the task is more complex. But sometimes you do get the odd person who might do better than you think, because the sentence structure provides more context to support comprehension. If their performance on reading was more impaired, say they predominantly made visually or unrelated errors, you could go up the model and test the orthographic input lexicon by using a written lexical decision task such as PALPA 24, where someone has to decide whether a string of letters is a real spelling or a non-word. If they made similar errors on both auditory and written word picture matching tests, this would trigger investigations for broader visual processing difficulties, some of which I mentioned at the start of the video. I'd also be thinking about broader attention and working memory difficulties. I'd also be thinking about whether the semantic system was itself degraded, i.e. actual loss or erosion of semantic representations, rather than it just being an access issue. You can investigate the integrity of the semantic system using something like pyramid and palm trees to see whether the person's non-verbal semantics is impaired as well, or is it just a language issue and they can match semantically related pictures fine. So that's how you can use the PALPA 48 to assess single word reading comprehension in someone with aphasia and interpret the results using the cog-neuro model. If you found this video useful, then consider liking it and subscribing to the channel. Maybe go watch my video where I explain how you can use drawing to explain what aphasia is to someone with aphasia. Otherwise, thanks for watching and take care.